Good morning, everyone. Can everyone hear me just fine from in the back? My name is Jason Smith. It's a pleasure to be here today to talk about, I guess we're going to talk a little more about history, especially based on the keynote. You know, we talk about how things are kind of old within, 18 months and you got to keep on your toes. But there are some things historically that, maybe were never well adopted. And I'll give some stats on this here in a minute, but you'll see what I mean. But we're going to talk about network flow data, and I'm going to kind of introduce this here's how to collect it. Here are some tools to use, specifically Silk, which was developed by Carnegie Mellon, as well as FlowPlotter, a tool that takes Silk data, makes it into some interesting plots, and as well as FlowBAT, which is a tool that Chris Sanders and I developed to kind of ease Silk users into flow data more easily. And there's a lot of barricades to entry that we've tried to overcome, and hopefully you'll see here at the end that in 10 minutes, if you don't already have a flow solution set up, in 10-15 minutes, regardless of your enterprise, and very little configuration, you can have a fully qualified flow solution. So just out of curiosity, and I know based on the previous hands up, maybe there's some shy, but who here is with like a NetOps group or a security operations group with defense? Okay. Who uses a flow solution already? Okay, so a few. Well, what I'm going to go over are a few different flow solutions, namely things that you can gather and deploy with relative ease, but especially, again, I'm going to go over Silk, as long as some scripts that will aid in actually setting that up. So my name is Jason Smith. I did not drive here from down the road, as it seems that almost a lot of people I've met are, they're within driving distance. I flew in here from Kentucky. I'm born and raised there, but I have been kind of all over the place working for state and federal agencies, and then moving on to Mandiant, which was then acquired by FireEye. With FireEye, I'm part of the threat analytics platform group. I work on making some rules with probably one of the best bunch of people I've ever worked with. I mean, they're great guys, never give us any problems. You see here, it's basically a death trap. It's a car I built with a buddy of mine, which now is from this Raspberry Pi enthusiasm I have, is a war driving and more dune buggy. It's a pretty fun car. But basically, I'm a junkyard engineer on the side. I throw together a lot of different cars into one and make a Mad Max type vehicle and drive it on the road. And it's a fun time. In Kentucky, you don't have to get things checked out for emissions, so it's a great place. Here's a shameless plug for Applied Network Security Monitoring. I won't go too much into what this is. A lot of you probably already know about it. Actually, David Bianco is here as well. He helped write it as well. But all proceeds to Applied Network Security Monitoring for the authors go to charities such as Rural Technology Fund, Hackers for Charity, several different other charities. Essentially, there are several chapters in the book dedicated to flow analysis, dedicated to how to set the stuff up and how to use it to detect bad guys. But even since this book was published, most of the work for FlowPlotter and FlowBAT, they kind of came afterwards when we were looking at it and saying, well, we reread this thing and it's still kind of difficult. There's still a pretty large barrier to entry. But now, at the end of this talk, I'll give you 6 commands that will erase all of that. I mean, it will make it to where, you can, jump into this book and any examples without any, prerequisite setups that you have to do. There's no work behind it. Again, several chapters go into it. You can follow along pretty easily. So today's agenda is all about flow data. It's obviously, I'm going to tell you it's very important, but I want to prove that it's pretty important as well. Show you how easily it is to use this to not really get answers, but get to your answers in significantly less time than you would if you did not have flow data available. How can you collect it? The answer now is very easily, actually. What can you do with it? A lot. And tools that can help. And when I say tools that can help, these are all free tools. So, obviously flow data is, if you've ever used it, oh, this is great, it gets us to where we're going. But probably the issue is that if you have new analysts, it's kind of hard to get into. Most things are either command line tools or, large vendor products, things like that. But, it's also useful for network situational awareness as well. It's good to have a tool that can be shared amongst not just SecOps, but also NetOps. And you would think that in environments where you have that kind of relationship, maybe you already have a flow solution, because why wouldn't network operations be monitoring network flows, or at least have access to them to look at the network? Well, when it comes down to it, there are a lot of large enterprises that have routing configurations and different hardware specs that don't even permit them to make flow data. And I keep using the word NetFlow, and that's kind of a misnomer, because Cisco's proprietary term is NetFlow, and I should really say flow or session data, because not everything is Cisco perhaps. But a lot of these flow solutions that are deployed by network operations, they're more for network health. So you might have sampled flow data, whereas sample flow data may be you take one record out of what you would have 100 records or 1,000 records, and then you only have that to look at data. You take large communication providers. A lot of those communication providers with 100 gigabit networks, they don't have access. Even those networks don't have access to flow data to use it for SecOps. Instead, they just have network health data that is just sampled flows. So right now in your operations center, or whatever you work in, you say, I want full PCAP, and it's great to have full PCAP, and it's awesome if you have a way to parse it. But there are pros and cons to it. It's very easy to capture. There's tools like Daemon Logger and NetSniffNG and DumpCap, and a lot of different tools that'll capture it all day long. A lot of them even handle rollover and rotation of logs. It's very easy to collect. There are, take Security Onion, by default it's collecting PCAP with no problem. You don't even think about it, and it's already there. It's easy to use for detection. You have tools that work directly off of it. I mean, you can take, practically anything, it seems, has a PCAP option to just drop a PCAP on it, even if you're not monitoring a network just live, and you say, oh, I have all this stuff from, Mila Parkour, and it's all this malware data. Well, I want to throw that into some tool. Well, like Bro will look at a PCAP, and SOAR can look at a PCAP, and everything can basically look at a PCAP. So that's great, but it's a lot of data still. The beauty of PCAP is obviously it gives you everything but the why, which you have to really determine yourself. The timeline at which you determine that is really what's important. And sometimes only having, even though you have everything, sometimes that doesn't count if you can't get to the answers quickly. So you have, again, the who, where, the when, and the what, but there are other things that can also give you the same thing. So, for instance, some cons to PCAP is, the biggest one I think of that you always hear people have a problem with is the actual, retention of PCAP. If you go into an environment and you say, oh, and you collect PCAP and you see a smile on their face, usually they're like, oh, yeah, it's great, we really leverage it all the time. I say, well, how much do you actually gather? Like, well, we have a week solid PCAP. And they're like really proud of it, and that's actually pretty good for even some large environments. But at the same time, it doesn't really help to determine, the guy got in 200 days ago. Really, how did he get in? Who did he pivot off of? What did he do? How much information do you really have? Well, if you're only focused on one data type that you think is the end-all data type, and PCAP kind of is, but you're not really powerful enough to look through that PCAP, constantly and see that, oh, well, 200 days from now I'll detect it. Well, I don't really know how he got in, so let's hope we can do something about it. It's also not really ideal for hunting. Again, it goes into the fact that you can't really just take a PCAP and say, I want to throw it in Wireshark. I want to look through all these packets. I want to find the bad guys, because this is easy to do. I have everything. And maybe you could do that with several other tools, but again, it's going to take breaking it down. And in the end, you'll find that, oh, well, now I've thrown it in to say, I'm looking at bro con logs, which, like bro faux flow, basically. So you're looking at some sort of flow-like data anyways to pinpoint where you want to look in the PCAP. Well, already it's, you should have had flow data. Another big point is that for analysis, and this goes back to the previous point, that in analysis it's not a great starting point. How often do you have some stored alert and you say, oh well, I wanted to look into everything. I'm just going to pull 3 days of PCAP for some host or whatever. I want to gather just around a certain time and then look at all these guys near it. Well, that's not very feasible. It's not easy to look at any given thing, even if you're a seasoned professional at this, let alone the junior analyst. You can't really take a PCAP and just automatically know what's in it. It's better to piece it apart, find what you want, and then you can dig into it and you're great. The big idea of flow data that I'm going to introduce today is that it's great if you do have this full PCAP, but it's not useful to you until you can actually find out what you want to look at. Flow data will allow you to do that. So the comparison of PCAP data versus flow data, best comparison that I can think about at least is, so PCAP, you might have a recording of a phone call. And to really figure out what's in that phone call, it's like you have to listen to the whole thing, pick up on what's in there, and you may be able to, let's say you have a transcript, you can, find whatever terms in the log. It's not too bad. But now let's say you have, 10 days of these logs, and maybe there's 100,000 of these a day, and you want to look through all of these all the time. It's not very feasible. You can't really do very good statistical analysis or anything on that. Whereas with flow data, you're not going to get the bulk of the data, but you get the bulk of what you want to start out with. The flow data really represents kind of like the call log of those 100,000 calls per each day for 7 days. You can still do something with that and then drill into what you want, listen to whatever phone call you want. Comparison to that, mountain versus molehill, cliche. But the difference being that if you can store hours or days or if you're lucky, weeks of PCAP, you can store flow data for months or years or indefinitely. I shouldn't even compare the months to that because I really don't know any organization who only stores a couple months of flow data. In fact, many large organizations that I've personally worked with store flow data indefinitely. If you ask them for their very first flow record they ever started storing, they will be able to retrieve it in no time. It's of great use to large organizations, small organizations alike, but mainly because at any given point it's not a bear to gather, and I'll show you later on again how fast it is, and it also takes up virtually no space by comparison to a lot of other data types like PCAP. For instance, roughly if you were to take a sample PCAP, and it varies a little bit, but if you take a sample PCAP and you process it through some of the tools that'll make silk flow data, the silk data will take up 0.01% to 0.02% of the same space that this PCAP takes up. Now obviously there are different data types that are used for different things, but it just goes to show you that if you're gathering PCAP already and devoting the storage for that, devote just a little bit for flow data and you can literally store it forever. So there's really no reason not to do it. It's easy to generate. It's very, very easy on hardware to generate, and you can generate yourself. You don't have to focus on network operations to give it to you. Also, just a little fact, if that were Mount Everest, 35,000 feet, then I would basically be the flow data mount. So flow data, often called session data, net flow data, it has a lot of different terms based on what kind of device you're generating it from. Again, there are some proprietary flow types, and I'll talk about those in a minute, not in great detail. But I've said net flow several times, and generally when you talk about flow data, a lot of people say, are you collecting net flow? Again, it doesn't always have to be net flow. That's Cisco proprietary. It's important to know that net flow data is not a summary of all the packets. It's the summary of all the network communications. So you may have the packet number in there. You may have bytes, byte amount. You may have record amounts of how many records are generated. But if someone comes up to you and says, I want a record of each packet, just the 5-tuple, then that really doesn't make much sense by comparison of the flow communication itself. The 5-tuple itself, as you'll see, is it's a source IP, source port, desk IP, desk port, and protocol. There's not much else to it. You see some other fields down there. Those are tagged along with it. So, for instance, NetFlow version 5, it's one of the older versions of Cisco NetFlow that was deployed extremely widely and still deployed extremely widely, has 20 fields. 2 of those are padding fields. However, there are other versions. You'll notice in some proprietary NetFlow tools, or flow tools, sorry, there are a lot of like unique fields like URI strings and things like that. Well, those are some extra fields that are put in the padding of things like NetFlow version 9, which actually has over 100 field type definitions. Then there's IPFix, which takes a lot of field type definitions above NetFlow version 9 and allows those to be configurable as well. Today, the example I'll show you uses IPFix, but just as a standard of a tool that's using it. The big differences between version 5 and version 9 and IPFix is that version 5 was not templated, whereas version 9 is kind of a templated approach, and a lot of these vendors can kind of do what they want to with a lot of the fields that exist. So here's an example of flow data just in a little text box. Looks pretty ugly, but flows really do kind of look ugly, like your communication log for your phone would look. But you can get a lot out of this if you have a good way to parse it. Again, here you have the 5-tuple as well as the source time and a byte count at the end. So building flow records themselves, what exactly is a flow? Well, again, I already defined what a 5-tuple is, but for the sake of this, it's important to know that, if there's a source IP, source port, des IP, des port, and a protocol, well, it comes into the collector. The collector says, oh, I see this. This is a unique combination within a certain time span. I'm going to put it in this bin. I'm going to hold it there for a while. And the while is a timeout that it's counting up. Well, if another communication comes in and it has the same thing but a different protocol, it will generate a different flow record. So these might be simultaneous communications going on at the same time, but it's important to note that only when that changes do you get another record, or when there's a timeout do you get another record. You can think of it as kind of an assembly line. This collector is bringing them in, he stores them in this little bin, he starts a stopwatch, and then he sets back, and these keep coming in. If another one comes in, he starts a stopwatch there. Well, once this stopwatch ends, he says, okay, go ahead and store that, it's ready for querying. Well, meanwhile, he's looking at another million records at the same time, and that's what this collector is actually doing. If it is like a new 5-tuple, again, it goes to a new flow record. If it is not a new 5-tuple, it gets appended to an existing flow record at the end of that timeout. These termination conditions are as follows. There are natural timeouts, which basically are if there's stateful protocols. The tool that you're using to generate the flow records themselves, it may vary on how it interprets these, but it's doing more than just stripping out some header data. It's actually looking at the data itself, and if it gets a certain flag or whatnot that says, hey, I'm done, it might say, okay, I'm going to close this record. It's ready for querying now. It'll tag it with an end date, and then you're ready to actually look at that data. Another is the idle timeout, which is pretty self-explanatory. These are all configurable, by the way. But the idle timeout, again, it's, okay, no more data is coming in for this guy. The decision's been sitting over here. 30 seconds gone by. Go ahead and put him into a record that is queryable now. Active timeout is if you have an ongoing communication. It just keeps going, keeps going. Well, at some point, you want to throw that into a record and make it queryable. Otherwise, you don't even know that it's happening. And so you'll have this. A common mistake, especially among junior analysts or people that are not experienced with flow data, is they may see a bunch of records that are these same times. It's like, oh, start date, end date. They're these same periods. This must be some sort of anomalous activity or beaconing activity or some kind of weird activity. Well, it's actually activity that they've defined to happen. It's just a timeout, a 30-minute max timeout, that an ongoing communication just keeps happening. So collection with flow data. So there weren't a ton in here, but if you're comfortable saying what type of flow solution you use, I would appreciate it. I've asked this in multiple different environments, but does anyone use, I guess say QRadar's flow solution? Okay. Anyone use something like Impulse or anything else? Does anyone use Silk? Okay. Does anyone use Argus? Okay, so there are a few different ones, pretty varied. So flows, the reason I started this by saying this is kind of a history lesson is because flows haven't really been adopted really quickly. In fact, the earliest usages of flows in cybersecurity were in 1991. And, here we are, and we still have, at least in most audiences I've ever surveyed, 10% or less of SOCs that actually have flow solutions deployed. Yet, in 1995 or 96, Argus was even available to the public, but it didn't get really adopted well. And the reasons for that are, kind of buried. Maybe it's that SecOps thought, okay, it's not on us to do this. If we need records, we'll ask network operations, and a lot of those might have it. But in the end, it is also probably due to the fact that it wasn't easy to really get this stuff set up. You would think that monitoring, just the interface and taking in some data wouldn't be so hard, especially when you're only getting this 5-tuple at the time. But it's actually quite difficult, and if the tools aren't available, a lot of organizations don't have the skill to set those kind of things up. So generating flow data, again, it's pretty easy, and there's multiple ways to do it. You can do it from hardware devices, or you can software generate flow data, which is what I always recommend to people if they have the ability to do so. SOCs, a lot of times they'll have some sort of network tap or some sort of port mirror, something that they're getting their data off of and running, generating PCAP from or anything like that. Well, if you're in that situation, there's literally no reason why you can't generate flow data on your own in an unsampled fashion. The last thing you want to do is to go to your network operations and say, hey, I know all you have is sampled flow data, but I still want it. It's better than nothing, but it's not much better than nothing, because in security operations and incident response, having that one communication summary out of 1,000 doesn't really help you. It may tell you about network health. You may see that you got a DDoS when you don't have network connectivity, or you see the spike or whatever in this health, but that's all that will do for you. You really want to have unsampled data, and the best way to do that is to generate it on your own, maintain the device on your own, and it's actually very easy to do so. There are multiple flow types, as I mentioned before. A lot of these, again, are proprietary, but there's, Cisco's NetFlow, and there's IPFix, and there's, SFlow and JFlow and NetStream and CFlowD and AppFlow and et cetera, et cetera, et cetera. Every vendor seems to have their own little version of flow data. A lot of the differences, though, is where they stick in proprietary information, and that's where it sets them apart. The big competition with vendors is that you have regular 5-tuple data that you can look through. How pretty is your UI, but also what else is in there that's not even flow related. It's metadata that's just kind of appended onto that. So popular platforms that, popular free platforms that generate flow data. I ask about Argus mainly because Security Onion has Argus in it by default. Not a lot of people seem to realize it right off the bat, but Argus is actually, not only being, one of the oldest solutions that were available to the public, but also, Carter Bullard was one of the first guys to really be using NetFlow for any kind of cybersecurity purposes. The pros to Argus is that, for a free solution, it does have metadata support. It's also very reliable. It's fast collection. It's bi-directional flows, which is, you could say that's good or bad. A lot of people prefer unidirectional. A lot prefer bi-directional. The difference being is that bi-directional is, if you communicate out and the guy communicates back in, that's one flow. Well, if it is unidirectional, the source IP communicates back out. Well, if another communication comes around and the source IP is different, the response communication is going to say that's a different flow. That's essentially the difference. The downside of Argus, and hopefully this will get changed at some point, is not very well supported as far as documentation goes. If you go out to the wiki, you'll find a lot of page under development since like 2012. But it is an extremely cool tool. It is already out there in Security Onion. If you've never messed with flow data at all, but you probably mess with Security Onion, go ahead and start that back up and just try to run some Argus commands there. NFDump is very easy to set up and use. It's very accessible. It's one of those things that if you weren't already versed in what flow data is and having an idea of what you wanted to go for, it's probably going to be the first thing you find when you start looking up flow solutions. The only downside is it's not really in incredibly wide use in very large enterprises. There are a lot of smaller companies that use NFDump, but not really large ones. There's also NFSyn that works with NFDump, and it's kind of a visualization tool that's pretty easy to get going. So Silk is the one I'm going to be talking about mostly today. Silk has awesome analysis tools. It's very easy to use once you get to using it, but it has traditionally had a more involved setup. For instance, Argus has its own built-in collector, whereas Silk, you generally use YAF or some other collector. It doesn't have its own generator. It doesn't have its own generator. It has its own collector, RVFlowPAC, which I'll discuss in a minute. But again, it's been a more involved setup. Later, the scripts will get rid of all that, though. It's not a big deal. It also has by far the best documentation of probably any tool I've ever used of any kind, not just flow data. Very awesome stuff. Awesome guys that work with it. If you ever get the chance to go to FlowCon as well, they're pretty much always there. It's important to note that Argus and Silk both were, without Carnegie Mellon, they probably wouldn't have happened. Carnegie Mellon is basically one of the biggest pushers of flow data, and they've made flows accessible to everyone, regardless of how your funding is. Silk, by comparison to some of these other tools, Silk can handle 12 billion flows per day pretty easily. And that's not just the analysis tools, but even RVFlowPAC, a single instance, might be able to collect all those flows with no problems if you can send them. Silk is unidirectional. So Silk is System for Internet Level Knowledge. Again, Carnegie Mellon has put that together. They still maintain it. They still do regular releases now. They had a hiatus for a while on public releases, but that's because they're also partly funded, government funded as well, so things have to go through review. But now they've had some pretty frequent releases. It's essentially two different things. There's the packing suite that when you send it flow data, it will pack it up into some files, and then you can parse that with the analysis suite. A lot of people use the term Silk database. Really, it's not a Silk database as much as it is a bunch of binary files that are stored in a directory structure that is basically the input. So when you actually run commands, there's this input switch. It's essentially looking in those directories directly, and that's why it's sorted that way. Again, here the documentation and community. The documents, there's not just references to obviously the tools, but they also have a analysis or an analyst kind of a workbook by which you can start out. It is like several hundred pages long though, but it's pretty awesome. The analysis suite, the main tool that you'll use, and I'll discuss in a minute, is this filter tool. The whole point of flow data is, again, to filter down to data that you really need. The main tool is called RWFilter. You'll notice that everything later on starts with RW, but it'll also display and sort and do everything you need to do to actually do any sort of analysis on that data. A typical Silk collection architecture, this is really simple. You'll have a F-probe sensor maybe generating some NetFlow version 5 or Senior. You'll have some sort of router that's sending flow data, and you have YAF or something that's sending some IPFix data. These can all be sending to this one Silk server that's running the packing suite, namely just RWFlowPAC is the tool that runs on there. It's collecting based on the sensor configuration. It says, oh, well, Senior F-probe is here, so you can define that as --sensor Senior F-probe. Or you have, the router or YAF or anything that you want. You can add any number of these, and again, RVFlowPAC can handle quite a bit of data. Then you might have the analyst workstation that has the Silk tools on it that then query from that server, that Silk server, or you have them SSH directly to Silk server, which is not always ideal for obvious reasons. So what you need to get going with Silk, you need a source. Again, I recommend software sources because you aren't being handed these things where that might stop someday, or we decided we would switch the support for this, or you're in control of everything. You are in control of all the unsampled data that you're collecting. You also need a Silk server, which could actually be the same thing. You can install it on the same thing depending on how much data you have coming in. The Silk server will again run RW FlowBAT, and it may also have the Silk analysis tools installed. I always recommend doing that just for debugging purposes. Even if the analyst isn't going to actually go look at it, it's good to have it. All they are, they're looking at that Silk data. Then you'll also have the analyst, him or herself. The analyst workstation may have the Silk server completely mirrored to that, or they can access the Silk server directly. Accessing it directly, obviously they'll need access to that data repository. But aside from that, if they can run the RW tools and they can access the data repository, they don't need anything else if they're accessing the Silk server directly. The analysis suite itself, again, RW filter, it filters stuff, right? So it'll filter through based on different conditions. Conditions have to have an input, which is, what kind of data are you looking at? That can either be a file that you've given it. Say you've generated some sort of flow data from somewhere else off of a PCAP or anything like that. Then you can just say RW filter, test PCAP.rwf or something like that. But you also have to give it a partitioning switch and an output switch. Partitioning switch will be, well, what data are you looking for? If you're looking for everything, I'll show you an example of that in a minute. RW cut takes binary data, which is the output of RW filter, and converts that to a human readable format. As I discussed before, Silk records everything in these binary files. Well, even after you process it with RW filter, it continuously just sends it to other Silk files. Well, to actually see that, you want RW cut. But you don't want to take RW cut output and grep through it and use a bunch of bash tools right off the bat, because generally the other Silk tools, they will do these things much faster. They are incredibly powerful. RW stats, it does stats, right? So it'll generate statistics based on a whole lot of different things. I'll show several examples later, but let's say you want your top sit-dip pairs, it'll do that in seconds. If you want the amount of unique country codes a certain source IP has talked to, it'll give you, okay, well, this guy's talked to 50 and this guy's talked to 31, and it'll give you the amount that they've talked to. It'll give you basically any kind of stats you can think of that relate to a 5-tuple. RW count kind of takes it away and looks at a much bigger picture. It takes bins of data, which data can be records, packets, or bytes. It'll bin all that up into certain configurable size bins to actually look at and say, oh, well, there were X amount of bytes in this minute, and the next minute had this amount of bytes, and so on. Pretty ideal for a line chart or something like that to show conditions over time. An example of RW filter. This is a pretty ugly example, and it's ugly on purpose because I'll show you an example of RW cut in a minute. But this is where you can draw all data. You'll notice I have -- type equals all. That is an input filter. I have -- protocol equals 0 to 255. That's just saying look at everything you have. That's the example I was using, that you have to have a partitioning switch, but the partitioning switch doesn't have to make a lot of sense. In this case, I just said give me all these protocols. When is that useful? Well, it's useful if you're using some sort of tool like RW count to just get a stat of your entire network. I also have -- pass equals standard out, which is saying go ahead and stick that to standard out, but of course you can't read binary. So RW cut says, well, I'll read that for you. And then it produces something like this, which is a lot of data to look at, which is why you generally want to knock things down a little bit. Here I've increased the partitioning switches, but right off the bat I want to point to the very end where it says RW cut -- fields. It's a much smaller output because I've said, hey, only show me what kind of data there actually is. I'm not exactly looking for the 5-tuple here, but I'm looking for 4 out of the 5, as well as the type of, is that inbound or outbound, and as well as the S time. Start time refers to, when that flow record was actually started out. So the partitioning switches here, we are looking for any kind of records to or from Chinese IP addresses over a specific week. Now it's kind of obvious once you actually start looking at it, but you have -- type equals all, so that means any kind of data, if it's in or out, if it's internal to internal, if it's external to external, which is an example of probably some sort of misconfigured sensor file. But you also have, we're going to look at where any port is 41.142. And by any port, it means where the source port or the desk port is 41.142. And you'll notice in the example that in every record, either the source port or desk port is that. And obviously our start date is on 8/1/2014, and our end date is a week later. We look at where any country code, be it source country code or desk country code in the record, is China. Here's an example of RW stats. In this case, we are kind of looking at a splash of all data. Again, notice the protocol equals 0 to 255. I would never put that in there for any reason if I actually had other partitioning switches, just because it's not really needed. It's inferred that it's going to be that. But we're looking at a splash of all data. These are statistics for the amount of bytes transferred by protocol, but only displaying the top 10. Well, you'll notice there's not 10 there. That's because it didn't see 10 protocols in the sample data I gave it. So it's only going to produce whatever I actually gave it. If I'd said dash count equals 100, it would still give you the same results. It's important to kind of read this, and when you actually write these commands left to right, so I'm literally looking for the top dash count equals 10 dash fields protocol by bytes. So you can kind of read this out in a sentence. And I always tell junior analysts that if you're using Silk at the command line, ask yourself what you're looking for. Ask yourself in a very plain sentence, what are you actually looking for? And you can probably type it out in commands. Here's another example looking for like what we think are valid conversations. We're trying to get valid conversations at least. Probably could have put in an additional initial flag setting there that would have probably hammered that a little closer to being accurate. But again, we look at a splash of data where these are conversations that we hope are legitimate. We're looking for the top 10 SIP-DIP pairs by bytes. And you notice there's actually been quite a bit of data. This was a pretty big set of sample data that's been anonymized. Here's another RW stats example. I like stats, as you can see. Here are the top 10 outbound destination country codes by records instead. I don't always hype on looking at how many records you have, because again, those can vary based on timeouts and whatnot. But here we are looking for any type of data that is out or out web data, which those are determined again by the configuration files for Silk itself. When you first set it up, it's a splash of any data that is out or out web. We're looking for top 10 destination country codes. A real world example, again, these don't usually tell you exactly the answers you're looking for. Sometimes they give you a pretty clear idea with few or no false positives sometimes. In this case, we're looking for some traditionally zero accessy ports. This is a splash of every bit of the data with the exception of ports outside of those. We're looking for the top source IPs by distinct destination country codes as the actual value this time. So previously we'd use things like bytes and whatnot. Well, this time it's counting up, it's looking at every single record that has these ports, and it's saying, oh, well, let me look at every distinct or every country code and count all those up, and then give me the guy that has anything more than 3 country codes where he's talking on those ports to some sort of outbound stuff. And here we have this guy right here who has 52 destination country codes that he's talked to. So 52 uniquely different country codes based on IP. Obviously, that's not always accurate, but you can pretty well be rest assured that you're not going to have 52 inaccuracies. Here's another example. This one uses quite a bit of stuff, and I don't expect everyone to understand right off the bat what all these are. I'll try to give a good example though. There are plugins, namely at mismatch, which looks at ports that it has coming in, and it says, did the data actually look like that? This is an example of app labeling, which the generator itself used, and it said, hey, this actually looks like, here for example, you say, this looks like HTTP traffic. Well, how many different destination ports use things that look like HTTP traffic? Well, it should have said, if it was all non-mismatched data, there should be 1. It should have been 80. Unfortunately, the app label doesn't always look at things like 8080 and other common web ports and things like that. But it saw 23 different ports in this data that were actually HTTP data. And again, as you go down through there, what it thought was something like SSH. It saw 5 different ports, so maybe you had SSH on non-standard ports or whatnot. In the query itself, it's looking for out or out web data. Anything's TCP where the source port is a high port. This time we did say we want a send flag as the initial flag, and we want to make sure that there are at least 4 packets in the communication. That should give you a better idea of an actual communication itself. And the RDB stats we're using, we're looking at application desk port pairs, where we're looking at the top 100, there are only 4, by distinct desk port. So collecting intelligence data, a pretty big fan of it, pretty fond of the idea that if you don't know what's on your network, then you probably don't have a really good idea what's happening on your network. Friendly intelligence gathering is just as important as looking for the bad guy. If you don't know what your critical infrastructure is, you don't really know what's being hammered, you don't know really what to watch more carefully. But it's very important to do this, and I'll show you an example of how to do this with Silk. Here's identifying SSH servers just by port. You can also do app label if you're using YAF. But here's identifying web servers, which is looking for reasonable connections and things like that. You could also add a threshold on that for larger enterprises to get a better idea. So actual detection with flow data. Over the course of detection in general, you've had signature-based things, like Snort and Suricata. You've had reputation-based stuff that you may, subscribe to a whitelisting service and blacklisting service that'll tell you some threat intel feeds and whatnot. Behavioral-based things like Bro are pretty cool, but a lot of people aren't using statistical-based things or using any sort of tools that allow statistical-based hunting. Well, Silk kind of does that for you, and for that, I've also added FlowPlotter. I wrote FlowPlotter to generate visualizations from these flow tools. It's very useful for basically generating any kind of thing on the fly to send to another guy or girl, whatever analysis group you have, and say, oh, well, here, my manager, here's this data you want to understand. Well, here's this plot too that you might have a better idea. It's a spike or something, and they'll believe you off of that, trust me. Here's a map, which is good for a dashboard. I won't go into the actual details of the queries themselves. You can look at those later. Here's a line chart that's basically looking at a splash of all data per 10-minute spans. Again, you just pipe that to FlowPlotter and say you want a line chart, 600 seconds by bytes. Here's a tree map. A lot of people requested tree maps. I don't really like them. So if you like tree maps, you can use this one. Here's a pie, bar, column chart. It's all the same data in the actual charts, but it's looking for high port stuff. This bubble chart, a little harder to explain, especially in the time I have, but it basically says, hey, are we looking at real communications, or are we looking at just maybe some scanning? You can do a lot of different things based on the query coming in, but it's basically a comparison of packets versus records versus bytes. So if you have a lot of packets per record, or if you have a lot of bytes per record, you can make some inferences off of this. More useful for the analyst actually looking at the data than sharing it. Here's a timeline of a given IP. This is this 172, 189, 124, 166, maybe you can't tell from this. But as it goes along, as you'll see, it's saying every IP it communicated with, when it communicated with it, and showing comparisons between each. Again, it runs like all the rest of those. Force-directed graph, it won't really lead you to any sort of, here's the bad guy, but it may show to your coworker or manager, here's an example of kind of what's happening here. And in this example, I'm showing, you can say, this is a blue guy, stick it over here, and we're going to say, oh, well, there's a bad guy or a good guy within here, color them red, color them green. You can do a lot of different things. For the sake of time, I'll let you see that a little later. Here is some asset discovery tools. So I showed you how to do a little bit of asset discovery earlier with Silk. Well, this will do it all automatically. So you see these servers that have been shown here, which there's web servers, SMTP servers, DNS servers, etc. Just running this one command, which has no options at all unless you threshold some data, will output something like this for your environment if you just have Silk running. This is pretty useful for determining what you actually have on your network. Again, your friendly assets. So analysis with flow data, kind of a summary of what it does for you. Previously, PCAP kind of gets you in a bind when you're actually reducing the data set. 35% of your first hour may be spent reducing that. With flow data, it takes that away and gives you 80% of your first hour to actually make decisions. You can pivot off your flow data straight to PCAP and understand what you have. There are barriers to entry. Namely, it's very hard for junior analysts to read, and it's a bear. Here is silk data output. It looks terrible, right? Junior analyst sees this. If you're good at it, you're one of those guys. You look like a monster because you're really weird and you stick to this all the time. But could there be another way? If you're an experienced analyst, you have the power already, but maybe you want more power. Well, we have FlowBAT. You don't need silk command line anymore necessarily. You can use FlowBAT to parse through all that silk data. It's a graphical front end. It uses Node. We use the Meteor framework to set it up. You can install it locally or you can install it via SSH. We've basically tried to take any of the things in silk, take those out if they were kind of bad deploy selections, and make it to where you can easily set these things up. So for instance, we have autocomplete, things like that, so you don't have to look up the commands you want. Even I still mess up some of these partitioning switches, and so you can autocomplete things. It'll find data really quickly. It'll also pivot off of data. You can look up certain ports, you can add things to the query. You can basically do anything you think you should be able to do. If you can't, make a pull request or make a issue. It'll also pivot off of other information. So I could click one of those IPs and look it up on RobText immediately without going to the browser. It also has a query builder for if you're not comfortable with Flow or with Silk already, you can generate all these things that you want to. For some reason, making that GIF didn't work for the help, but all those help bubbles work. It'll add up all the Silk queries. So if you want to learn Silk, you can do it straight off of this. If you want to, those are all sortable columns as well. This is going to make some stats right now, but even in the actual flow data, you can take those columns and sort them left to right without actually running new queries. So Silk data and FlowBAT, if you want them, you could have had them at the beginning of the talk and had it in like 10 minutes. Run these commands and you'll have completely set up. You'll just go to go to FlowBAT and you'll set it up in the configuration of FlowBAT. And next thing you know, you will be able to look at data. You'll probably actually see the data that you just collected while you downloaded FlowBAT, actually. I'm probably going to minify this in a few weeks too, so it's going to be one command instead. You'll just curl FlowBAT install pipe.sh and it'll be installed in probably around 4 minutes. So in conclusion, flow data, very underused, very underrated. It's been around forever, but only 10% of us are using it. We should really be using it more because we could be saving about 35% of our time per every first hour of any sort of incident response or any sort of event that you're looking into. Minimal barriers of entry. Argus is in Security Onion already, so you may actually already have Silk data out there or flow data out there. And then obviously Silk, again, I said in a few weeks, 4 minutes of time. Right now it's a whopping 15 minutes to deploy NetFlow in your enterprise. So it's pretty easy to use. If you have any questions, I am again Jason Smith, cheesy Jason Smith Gmail address here. It's very hard to get a good Jason Smith address. Go to Applied NSM if you want to know more about the book. Buy the book if you want to donate to some charities and learn a lot of stuff. FlowPlotter can be reached there, and FlowBAT can be reached there. Go to FlowBAT's installation page if you want to know more about the actual installation so you don't think you're downloading a bunch of malware. And that's it. Any questions?